All right. Well, I think we'll get started with today's webinar. I'd like to welcome everyone to our last webinar of our series titled Conservation Remote Sensing 2. And this series is sponsored by the Society for Conservation GIS and also the Conservation Biology Institute. My name is Janet Nakoni, and I'm president of the Society for Conservation GIS. I'd really like to thank Peter Becker for being our webinar presenter. He is a project manager for imagery at Esri, and the title of his presentation today is Integrating Remote Sensing with Conservation Analysis Workflows. So before I pass the mic to him, I just wanted to cover a few details about the webinar. As the other webinars that we've had, we always record our webinars so that we can make them widely available and archive them on our site. So after this webinar, maybe about a week following, we'll be posting this recording to our website at scgis.org. I wanted to show you, you can actually view all of our past webinar recordings. If you just simply go to scgis.org, if you go to the training tab and go to webinar recordings, you'll be able to see all of our different previous webinars that we've had. It's a really great resource. I really encourage people to go there and visit these webinars. I'd also like to make a plug for the Society for Conservation GIS. If you just go to our membership page, if you go to the About tab and go to About Membership, you can read through all of our different benefits for members. We have a lot of great benefits, including in the context of today, we have free access to technical videos from the Esri Users Conference. We post those each year. We also have free access to our thriving listserv. We provide discounts to our annual conference. And I wanted to remind everyone, we do have an annual conference coming up in July. It's going to be right after the Esri User Conference in Monterey, California at the Asilomar State Park. This is a really great opportunity to meet other conservation GIS folks and to network and listen to a variety of presentations and attend a lot of technical workshops also. SCGIS is a volunteer-driven organization, so I really encourage all of you who are interested in SCGIS to learn more about it, to sign up for membership, and also to consider becoming involved with SCGIS. We have a lot of different committees where you can, contribute to SCGIS's mission and help out. You can also help us with our conference coming up in July. We're always looking for more help. So with that, I'd like to turn it over to Peter. Thanks a lot, Peter, for presenting in our webinar series. We're really excited about what you have to share today. So I'm going to stop sharing here and hand it over to you.
Okay. Thank you, Janet. Can you hear me?
Yep, I can hear you and see your screen. Looks great.
Great. Okay, thank you very much for this opportunity to present to such a great organization. The title today is going to be Integrating Remote Sensing with Conservation Analysis Workflows. So to start with, just a little bit about myself. My name is Peter Becker. I do product management at Esri. I've been working at Esri since about 2005, focusing really on our imagery components, specifically our server components and how we really serve massive amounts of imagery to users. What I wanted to start with at a high level is just to really talk about what we mean by analysis workflows. And that's really to talk about how to complete a complete project, we really have to go through lots of different things from, collecting data, visualizing the data and mapping it, performing different types of analysis and modeling, doing then planning and design, and then creating the interfaces to enable decision making, and then hopefully taking action that is beneficial. So this really brings together the concepts of observing and measuring, the informing, understanding, and then teaching and collaboration. So it's all encompassing to go from A to Z through a workflow. Before actually going, and obviously remote sensing is a key component of this, and I'll be focusing really on the remote sensing and components of this. But before we actually go into that, what I wanted to do is to sort of talk a little bit about how do we get here, and look a little bit, look briefly into the past. So if we go back in the early 60s, really a young geographer and former RAF pilot, Roger Tomlinson, was given the problem of trying to predict the best location for forest plantations in Kenya. He really conceived the idea of manually overlaying many different types of landscape and topology, geology, water, climate, and in order to calculate place-based analysis across many different overlay combinations. He then figured out how to use a computer to do the same thing, and quickly and precisely went on to create the Canadian or Canada Geographic Information System, which is really the world's first GIS. It was actually Roger Tomlinson's ideas that helped inspire Jack Dangermond, who was a student at Harvard Graduate Design School, to focus on GIS. Jack worked with Carl Steinitz, who headed the laboratory for computer graphics and computer analysis, and worked on some of the earliest ideas of how GIS evolved. Jack's colleagues at the time included many who would go on to found other GIS institutes and organizations, including Laurie Jordan, who was a co-founder of ERDAS, one of the first remote sensing companies. And Jack founded, at that time, the nonprofit Environmental System Research Institute in 1969 as a center providing consulting and geographic project support, primarily to resource agencies and planning departments. And at the time, GIS was viewed as an integrative tool, allowing many different kinds of ecological data and measurement to be combined for better analysis and management. In the 80s, Esri began creating its own GIS software, and by then had transitioned to a private firm that was more efficient, institution for developing GIS tools for environmental purposes. In the early years, there were really two basic models of how to model the world. Rasters in the form of remote sensing, optical imagery, thematic and categorical data that was used by ERDAS Imagine, ENVI, and ArcGIS Spatial Analyst. And then there was the vector world, which is really dominated by ArcInfo and its use of topology to enable modeling. Since then, the two disciplines have really merged together, with Esri encompassing both models into ArcGIS. And this was really directed by Scott Morehouse, who led the development of ArcGIS for many years. Over the years, the Esri team has been joined by Laurie Jordan, as I mentioned before, a founder of ERDAS, as well as more recently Richard Cook, who was for many years the president of ITT Excelis Geospatial. Under Jack's leadership, Esri has grown and thrived through 6 tectonic shifts in the computer revolution, from mainframes, personal computers, database systems, and the internet, mobile devices, and in through to cloud computing. Today, hundreds of thousands of scientists and professionals use ArcGIS, which drives an ecosystem of thousands of interrelated and interactive tools and apps. And it's really these kind of resources that enable humanity to better understand the Earth and how best to make smart decisions about our future. So, Esri's focus from its founding has been in conservation. In the 1980s, Charles Convis from the World Conservation Monitoring Center in Cambridge joined Esri to help start a new international support program for conservation. Inspired by the annual Esri User Conference, Charles organized the first Conservation GIS sessions at this conference and wanted to help non-profit users attend. So he found travel funding and provided housing to these first Conservation GIS folks so they could afford to get together and get to know one another. SCGIS itself grew into an official organization in 1997, thanks to the founding endowment from Jack Dangermond. And Esri has maintained a 30-year-long relationship to support SCGIS in many different areas. So here are a couple of snapshots from the past. Top left is a GIS demo at Stanford that includes Paul Ehrlich, famed environmentalist, and Michael Soll, who was actually the founder of the Society for Conservation Biology. Bottom left is Charles Convis and Jack, with Bruce Babbitt, who was the US Secretary of the Interior and gave a keynote speech at the 1996 Esri User Conference. And Esri has always been a very strong supporter of SCGIS that provides major sponsorship to the annual SCGIS conference, as well as sponsoring 20 to 40 international conservation GIS workers yearly to come to California for 4 to 6 weeks of intensive conservation GIS training. Every year, Esri holds its International User Conference in San Diego, and all SCGIS members and scholars are eligible to apply via the Esri Conservation Program for free attendance. We certainly hope that many of you will be able to attend this year's conference in about 1 month's time. So that was a little bit about the sort of the background of how we got to where we are. So how is actually GIS being used? Well, it's in many different areas. Certainly environmental monitoring and asset conservation. It's used in all sorts of ways for land management, working out quality risk of water, marine spatial planning, conservation planning. So there's just a couple of slides showing some of the uses of GIS, ArcGIS in these different areas. Similar, it's used for forestry and land management. And here's some more examples of it, different components of ArcGIS being used for example, for field operations or timber management. And also, for example, for forest fire planning. In other areas, for example, transportation planning and management. Here are examples of the use of ArcGIS for transportation type applications, including sort of the monitoring of things like cargo vessels. Then in public safety and national security for things like fire risk management or event tracking and things like crime analysis and human trafficking. So these are all sort of areas that are used. Natural or disasters, or preparing for these disasters, from modeling hurricanes to using high resolution imagery, for example, from vectoral imagery for fuel and fire extent assessment. So when we actually look at the conservation technology landscape, what you will see is that it's been around for 30 years, and it's actually created out of lots of different components, which are very often disconnected, fragmented, and require manual transfer of data. There's a lot of things like spreadsheets, applications for single purposes, and things are very often disconnected. That's really what we want to try and do, is to ensure that this all really comes together very cleanly. And the way we do that is really with what ArcGIS refers to the Esri Geospatial Cloud. So this is really a collection of a lot of different technologies and systems which integrate together to really fuel the geographic science. So there are various components to it. One of them are the apps, and the apps are really about bringing the location to everybody. So it really, apps are typically run on mobile phones or tablets, but can also work on desktop and applications, but are really focused to allow a user to quickly understand and utilize a focused a workflow. So an app is typically has a limited number of buttons on it, but it really leads somebody through a complete workflow and enable them to get their tasks done as quickly as possible. So lots of different apps. From just viewer apps, but also apps for designing, and also sort of dashboard type applications. Obviously, going in the field is very important. So Esri provide a lot of tools for working in the field. So these are tools, for example, Survey 123, which is very a tool for collecting form information, Collector, which is very good, especially for collecting, for example, control for GPS or other measurement information, but then it also integrates with things like Workforce and Navigator to provide the best route for getting from one place to another. So these are all sort of field solutions which provide the ability for large groups of users to work in the field with access to all the data they need and the ability to collect more information. And then real-time analytics is also important. So within ArcGIS, we do a lot of bringing in of a lot of high-velocity data streams. They might just be things like stream gauges, or they could be the locations of vehicles or planes, or all sorts of mobile assets, which need to be monitored in real time, and then decisions being quickly made based on their location or their projected location. Dashboards, I've mentioned very briefly before, they're also important to enable all this information to be very quickly reviewed, and this is especially important for decision makers who really want just an overview of what it is, but and see a live update of what's going on, but then can quickly query and investigate more what's actually going on the ground. From an imagery and remote sensing perspective, ArcGIS includes a lot of different components, and imagery is really integrated deeply within ArcGIS. So this diagram really just shows sort of the general flow of data coming from remote sensing or from sensors. They could be satellites, planes, drones, or terrestrial sensors, or they could be data sets that already exist. And these can then be loaded into either on-premise storage or cloud storage, and then accessed and then basically served through ArcGIS and made accessible to lots of different web, desktop, and web and desktop applications and mobile applications. From an imagery perspective, we really break the capabilities down into 5 key capabilities. One is the aspect of image management, and this is really the tools within ArcGIS, which allows you to manage massive volumes of imagery, millions of images that an organization may have. They can quickly manage those and create what we call mosaic data sets, which enable the data to be very quickly accessed and then served and streamed to users in various applications. So for organizations that have massive amounts of imagery, that's really the optimal tools for managing and distributing that data and making it accessible. The other aspect of map production, that's taking the tools, the imagery that you have, maybe from a drone or from a satellite sensor, and then creating different products. And these products are typically things like orthophotos or digital terrain models, so ensuring that the accuracy of the imagery becomes accurate and can be used for lots of different types of analysis. So that's really all part of the map production, and includes things like stereo viewing and extraction, which is important for certain types of data. The third component is the analysis, and this is really about extracting information from the imagery. You have this imagery and you want to extract extract information, run analytics on the data, and this may be just simple visual analysis, or it could be doing more detailed analytics that is actually looking at all the data values, performing things like classification or deep learning against the imagery to extract information from that data. And a lot of that result of that analysis may be additional raster data, or more likely it's more points, features, and polygons which are extracted out of it that feed into the system. And the fourth component is really the visualization and exploitation. And this is really the tools, both in desktop, mobile, and web applications, that allow users to quickly interact with that imagery and make decisions very quickly. And I'll be showing some demos of how this all works. The fourth component is really content. So ArcGIS provides massive amounts of content that we make accessible to users, so that they can use that as the base for not only visualization applications, but also performing lots of different types of analysis. So these are the sort of the 5 key components that make up the imagery platform that ArcGIS provides. This is actually done in various ways. From a product perspective, there are various tools, for example, ArcGIS Pro and the Image Analyst extension. These are really tools that enable you to work in typically desktop environments and provide a wealth of capabilities for managing, modeling, and analyzing data. Those same tools are then actually available in ArcGIS Enterprise with the ArcGIS Image Server. Those are the tools which actually run, or the server components to run on servers and then serve all that information out to users. So if you're an organization and you want to run your data behind a firewall, you can set up ArcGIS Enterprise and Image Server and then serve that imagery to your users and perform lots of different types of analysis with the processing being performed by the server. Alternatively, or in parallel, you can actually use ArcGIS Online. So ArcGIS Online really provides a SaaS offering with a lot of visualization analysis capabilities for users who really just want to connect to a service and just directly use the services. And these services, whether they come from ArcGIS Enterprise or from ArcGIS Online, can then be used by the various applications. They include ArcGIS Pro and the Image Analyst extension. Again, those in that case, they're acting more as a client to the servers, but also for applications. For example, Excalibur is an application that we've brought out very recently for observation management. And then also through lots of different APIs that provide integration with all the different systems and include all the sort of OGC, WMS, WCS, WPS, and all those sort of standards, which allow additional integration into other systems as well. So Let's talk a little bit about the content. So ArcGIS provides massive amounts of content. This is not just imagery, but this is ready-to-use maps and data sets that provide things like base maps, information on or imagery, scientific data, demographic data, elevation data. There are hundreds of thousands of data sets that are actually available through ArcGIS Online. So there are over 100,000 just open data layers, and a lot of this content comes actually from users. So a lot of our users, and a lot of you hopefully, are sharing your content through ArcGIS Online to make it accessible and able to be mashed up in lots of different applications. We really provide the sort of the foremost collection of global geographic information content in what we refer to as a living atlas of the world. Living atlas of the world is really a component of that, which brings together content from lots of different organizations and really tries to bring the authoritative content together and curates that to make that easier to access. And that includes lots of different base maps. So these are not only raster base maps, but vector base maps that can be easily integrated into applications, massive amounts of imagery, including global 1 meter resolution or better imagery, as things like Landsat, Sentinel, as well as things like GOES. So massive amounts of imagery accessible, but then also brings in data feeds, real-time feeds for example, drought monitoring or stream gauges, and as well as demographic information that can be used not only for visualization, but for a lot of different analysis. So this is really putting all this information, making all this information accessible to you. So let's actually have a look at a couple of demos of this. So I'm just going to have a look into the living atlas of the world. So here we see really just the gallery that provides an ability to search and have a look at different things. So if you're looking for base maps or imagery or boundary information, you can quickly get access to the data or perform a search to find these different items and get information about the items. All of this content actually goes into applications. So this is actually web app, which allows you to actually add content from lots of different sources. So here's just a web map that I've created earlier. And it contains different data sets. For example, I can turn on Landsat imagery, and this will actually provide me access to Landsat imagery for the whole globe. It's actually updated every day. So every day we add hundreds of new Landsat scenes to this data set that can be easily added. I'll talk some of my other demos. We're talking a little bit more about the Landsat data. But if you wanted to add other data, you can just sort of search for layers from different sources. They could be web layers, or they could be from a local file, or you can just browse the living atlas. So to browse the living atlas, you can type different things. For example, terrain, and it'll bring up different type of terrain. If I, for example, get information about this, you'll find out this is actually a multi-resolution elevation data set covering the entire globe. It actually comes from hundreds of different data sources. So we can just add that to the map, and it'll appear at the moment it's being displayed as a grayscale image just showing elevation. But as a user, I can go and modify it and change, for example, the image display and say I want to actually see this as, let's say, as hill shade. So go apply, and the hill shade is being applied. So these aren't static layers. These are what we sometimes refer as dynamic image services, which means that the data is coming from lots of different sources. And as I pan and zoom around, the requests are going to the server. The server is then processing this data from the original data sources, in this case, creating a hill shade and returning that back to me. So I can zoom anywhere, and some of this data is incredibly high resolution. To provide, so you can get quick access to the data. If you want to change the rendering, you could, for example, say you're interested in, for example, slope, and go apply slope, and you get, for example, slope maps. Or if you wanted, let's say, elevation tinted hill shade, apply that, and you get a sort of more cartographic pleasing representation. So these are actually what we call dynamic image services, and the client applications cannot just view the imagery, but they can interact with the imagery, transmit requests to the servers, and the server then performs that processing and returns the result nearly instantaneously to the applications. So this is sort of a web map, and the web map is really the foundation for a lot of different components within the ArcGIS platform. So you can add all different types of vector data and from lots of different sources to the data. You can then save it, and then you can actually go and share this data as different things. So you can create an app, or you can actually create so we can say basically create an app, and there are lots of different apps that can actually be created. These are configurable apps, including actually what we refer to as story maps. So story maps are really the ability within the system to very quickly create basically a story. So you can take your maps together and quickly bring together various imagery and information. Best thing is actually to look at an example. So if you go actually to the website, you'll see it basically talks about the various story maps, and you can actually go to a gallery, and in this gallery you can get information about the different story maps. There are hundreds of thousands of story maps that are being put together by all sorts of people covering all sorts of subjects, and you can basically just go and search for something. I'm just going to say, for example, salmon. And you can see these are just the story maps, just purely about salmon. If you're interested in one, basically pick one. This is from, I think this is from the wildlife. Let me just go back to that one. That one looks as if it requires a login. Let's pick another one. So you can basically go through these story maps, and they basically drive you through a very nice interface talking about different aspects that want to be covered. So these are sort of typical story maps that are put together. So let's go back to the web map that I had. As I said, from the web map, you can share web maps in multiple ways. One way is to take this information and include it into a story map. The other way is to actually share it and actually create an application. And there are lots of different templates that are used to make these applications. You can use Web App Builder, which is really a much more from a programmer's perspective. You can basically write code with JavaScript and integrate it very quickly, or you can use these pre-configured applications. And for imagery, for example, there are 3 different applications that exist. And if you wanted to create an application to do, for example, masking of data, I can just sort of create an app, enter some information about it. SCGIS summary, demo, go done. And what it's actually going to do is to actually create this map for me. Which is not going to do right at the moment. Yes, it is. So this enables you to actually put together apps very quickly. It's actually configuring the app, setting up the different widgets within it. And here we basically have the application. It creates a web map. It takes the web map that I started with and starts that off. And then I can change various things like the different themes that I want to see. And I can define various options for the different tools. If I want scale bars, then I can actually configure the different imagery sources that are in the data, and define things like attributes which define the date of the imagery and things like that. So basically, you can very quickly configure the app. The result of this particular app, I'm not going to build it all. This is the app that's actually being created out of this. It's a very simple app. In this case, it's an example of how to do burn scar detection. So this is based on the same web map that I showed, which had access to the Landsat data. But we can now go and actually do burn scar detection. So let's, for example, go and look at Lake Elsinore. In California. You can basically zoom in there, and we can actually see the Landsat imagery is immediately displayed. And we can certainly already see the burn sky in this particular area. But what if we actually want to go and actually look at this in more detail? We can actually turn on these tools. And one tool allows you to actually, let's say, pick the different data set and choose a specific date. So we can actually go back in time and have a look at this. So if I choose the date and actually go back to, let's say, August the 8th, if I can find August the 8th, what you will see is the system is basically essentially changed to see that image, and you can see that this is an image of the when the actual fire was raging. So we can quickly access that. But we can also get different band combinations. So if I go, for example, to the shortwave infrared, I can see that. And let me just go and pick that particular date again. So it's actually interesting to see how you can actually really see, literally through the clouds, and actually see the extent of a particular fire. But if I wanted to actually do some other analysis, let's just go back to the later image. Let's go back to actually not color infrared. Let's go back to agriculture. And let's actually pick two different dates. Let's pick the December as one date. And then what I actually want to do is to actually do an analysis and actually compare the imagery with the previous. So I can go into, for example, change detection and pick two dates. One is going to be the 30th of December, and I'm going to take the next one. Let's go back to, let's say, the 23rd of July. And then what we can actually visually easily see is the difference between the before and after the fire. So a simple swipe tool allows me to visually select this. But what if I wanted to do more information? What if I wanted to do some type of analysis? I can actually ask the system to do, for example, create a change detection based on a burn index. And if I apply that, what it's actually going to do is to compute the burn index for the two different dates and then subtract one from the other. And then we can actually really see is in the areas in the sort of magenta color are the areas where the burn index is significantly increased over that time. And that would obviously be the extent of the burn areas. So we can visualize it this way. Alternatively, I can create a mask, apply that. And what the system is going to do is to create a mask. So it's computing the mask and transmitting it back to me. And then interactively within the application, I can quickly sort of change, reduce the or change the tolerances to identify, let's say, the extent of the fire. If I want to actually compute the area of that, I can actually just draw a polygon around this area and apply that. And what it's going to do is to do the same computation, but compute the area that's been involved. So you can see how you can use that to very quickly identify things like flooded areas or burnt areas or changes in agriculture. If you wanted to, you can just save this as a layer, or what we can do is actually go on and actually add some notes and vectorize it. So I can go into these tools and, for example, just quickly draw the extent of my fire, just to sort of say, okay, this is actually the area that I'm interested in, and put some information in it. This is the Hottie Flyer, and I can maybe add an attachment if I wanted to, and then basically close this application. And this is now recorded, and it's within basically it's a layer within ArcGIS Online that can be used within other applications. So this is a very simple application that can be put together literally by a couple of mouse clicks. You can bring together different data sources and do that. The same APIs can be used, mind you, to create much more advanced applications. So this is actually Earth Observation Explorer. It's an app that we've just brought out. It's a free app that anybody can use, and we can do similar things. You get access, in this case, to all the Landsat data of the world. But if I actually let's zoom back into Lake Elsinore. Let's go back to that area. So here we're looking at Lake Elsinore. The app looks very similar at this particular case, but I can go into here and have a look, for example, the Landsat data, but I could go and say I'm interested in Sentinel data. So this is going to give me access to the Sentinel-2 data. And again, I can go through time and find different dates and time. And what's going to do is it's transmitting a request to the server. The server is actually going to get the imagery from that particular date and return it. But similar, I can go and say I'm interested in different band combinations and get access. It'll then process and return that information. Similarly, I can do the same thing with Landsat data, or I can actually compare. If I do the compare tool, I can actually compare Landsat and Sentinel again but between each other. Or create things like masks. So if we take, for example, the Landsat imagery, and I can pick, as before, a particular date. So let's just pick a date, 14th of October. And then I have access to these different tools that allow me to create masks of things, create spectral profiles, or even do things like create spectral scatter plots. So this can actually be very interesting. If you basically select the imagery, you can actually specify the scatter plot you want based on 2 different band combinations, and then see what the scatter plot of this particular area looks like. If there's something that looks interesting to you, you can just highlight it, and it'll pick up those particular areas. Similar, if I pick a point in the map, it'll actually show me that area in the where it is in the scatter plot. So there are all sorts of different tools here for creating masks and spectral profiles. So it has a lot of different capabilities. If I'm interested in a particular image, I can actually save this as a layer within the system. Or what I can do is to actually add additional data. I didn't mean to do that. If I actually go save, I can actually export this in different ways. I can say I want to export the image. I can define the extent of it. I want to say, in this case, I can either save it to a portal, or which becomes a layer, or I can save it to disk. So I can say I want this particular area. Go save, and here I can define the different resolutions and the coordinate systems. If I save, this is actually going to create in this case a TIFF file, and we'll come back to this TIFF file. We'll come back to this TIFF file in a minute. So it's a simple application but it provides a lot of capabilities for working with massive amounts of data. We're talking about over a petabyte of Landsat data, and probably the same amount of Sentinel data that's available directly in the application for anybody to use. And so not just we're going through all the different dates and also get access to all the different band combinations, even the ability to, for example, define your own band combinations. So you can define your own band combinations if you want. So this is really the apps. The apps there are lots of different apps that are created. An example app that I wanted to highlight is actually from Clark Labs. They actually have released what's called the American Land Change Modeler and a similar Explorer application. This is actually available in the marketplace, and what it actually allows you to look at land change over time. So it uses basically a land cover database and many different variables to calculate the likelihood of a particular location to change from one land use to another. And this can also be used to actually forecast land cover into the future. So it's a very interesting application. I would suggest you have a look at. Within ArcGIS, the web apps are just one way of working with imagery. The other way of working with imagery is to use ArcGIS Pro. So this is really our professional GIS desktop application that provides access to all the similar tools and much more. So this is exactly the same web map that I loaded before, and you can basically access these web maps. And within ArcGIS, you can then get access to a lot of additional tools as well. So there's actually an imagery tab, and this imagery tab provides a lot of different capabilities, including, for example, the raster functions. These are actually a lot of image processing and analysis tools. There are literally hundreds of these tools that you can chain together to perform all different types of image processing. So what most people don't realize is the extensive capabilities or image processing and analysis capabilities that are available within ArcGIS. And so this is not only to do with raster functions, but we also have things like classification pools. So you can do all sorts of different types of classifications on the data. And if you want to bring in local data, if I actually drag and drop, that's the data set that I just added. So that was that data set that I exported previously from the web application. I can just bring it in to this application as well. Here you actually see the burn index that I actually drew in the web application immediately now appears in my ArcGIS Pro, because it's using the same data source. So in the web application, I was drawing the different extents, and in Pro, for example, I can view those extents. So it's really integrating all this different data. So within ArcGIS, there are a lot of analysis tools. So these include various spatial analysis tools. So it's not just about working with optical imagery, it's about working with all different types of rasters. And there are a lot of very advanced tools to do things like distance functions and hydro functions. And these functions work both on the fly, in other words, as you pan and zoom, they're processing. Some of these functions, mind you, are what we refer to as global functions, are literally impossible to do on the fly and are typically done in a persisted analysis. So we use the ArcGIS server has what we call raster analytics, and that's the ability to perform these analysis in distributed computing using distributing storage to really enable massive data sets to be processed extremely quickly. So it's really making available analysis that was available with previously only possible with supercomputers. We can actually now do this with using a cloud infrastructure and ArcGIS image server performing the parallel processing of the data. There's a lot of machine learning tools as well. So these include lots of different tools for doing different types of classification, pixel and object-based classification, but also various types of clustering, hotspot analysis tools, different types of prediction, various types of interpolators, advanced interpolators are there, and then also the deep learning to basically create and classify different types of pixels. On the deep learning side, we actually have a really clean workflow which allows users to actually create the training data and then enable an image scientist to use notebooks for actually training the models. And the result of that is what we call a model definition. It's really it encompasses all the different models of the neural networks into a model. And then the inferencing tools can be easily used by any user, just literally selecting the model and the input images, and the inferencing tools will then apply that and actually create the inference results, which might be various types of feature extraction that you might be interesting. So it's very, very clean workflow through the whole deep learning aspects of deep learning. So from a deep learning, we really go from labeling the imagery, preparing it, creating the different chips that are actually required to send into the training model. Those training models are then basically run to create the model, and then we can actually create the different analysis. And the result of that analysis may, for example, go into field mobility applications and then monitoring applications. So it really is the complete workflow from the raw imagery really into the applications for monitoring the results of the different type of analysis. These workflows are all documented. There's actually a site specifically focused on different imagery workflows. I'd recommend you go and have a look at it. And there are also learn lessons, which will actually lead you through very quickly how all this works and gives you the ability to actually test all this out on your own data. ArcGIS also integrates with notebooks, so with Python notebooks, and so these really gives you a great ability for more those users who prefer to use notebooks to integrate all the different analysis capabilities that are available within ArcGIS can be accessed through these notebooks with very, very tight integration. So it really is a great way of working. And if you go to ArcGIS.learn, you will see these Python modules which are specifically designed for doing the training to train up the different types of models, whether using CNTK or TensorFlow. So all those models are available through ArcGIS Learn. So let's actually talk about the complete system. So it's really from a conservation aspect, what ArcGIS is providing is really a complete system that brings all these different components together. It's not just the imagery, but it's bringing together the real-time data feeds, the different data sets coming from the Living Atlas, different layers that you as an organization or other organizations may be creating. And all these can basically bring together either through ArcGIS Online or through ArcGIS Enterprise, and then made accessible to all these different applications, whether they're for applications for surveying something or inventory control or planning and monitoring applications. So it really brings all this data together. So from a conservation platform, we provide not only the content, but the various apps. And then I'm going to talk a little bit about the different types of solutions that could be put together, as well as all the different education, the implementation guidelines, web tutorials, ebooks. There's a lot of information available to you. And it has the system has massive capabilities for working both in the cloud. It's configurable, and the ability to create these on-demand applications, as I showed you before, that also integrate all the remote sensing analysis. So ArcGIS really is an open platform. A lot of people say, "Oh no, it's proprietary." No, there is components of ArcGIS that is proprietary, but it really is an open system, an open platform, and that we really work with massive amounts of open data. We support better than anybody all the different open standards. We have open APIs that enable the different integrations. We have the open communities. We utilize a lot of open source and contribute significantly to the open source projects. And also very much work with open science in working with things like CNTK and pandas and stuff like that. So it really is a complete system which is extremely open in its ability to work and integrate with all these different systems and become really extensible and interoperable. Another key aspect is actually the security of the system, and a lot of people don't realize the amount of required and what the emphasis that Esri puts to ensure that all the data is very secure. So ArcGIS, for example, is available on FedRAMP. It's accredited for FISMA. So we really have put a lot of effort into ensuring that the system is set up such that you really are retaining ownership of any data that you have, and you can have very strict controls on how that data is made accessible and who can access or not access the data, both in the cloud environments or on ArcGIS Online, but also in the enterprise environments. So if you're interested in the security aspect, look at that URL on the bottom right. So from a conservation, just quickly on the conservation solutions, we talk really about talking about workflows, but workflow is really one component of it. It really is how the different things can be put together to create to enable a task to be performed. But what we do is to combine those workflows with roles. Roles are really how a person joins an organization. They're typically given roles, and within those roles they are provided access to specific applications and specific functionality. So when you combine the workflows with the roles and then the applications that have access, that is really what actually comes up with a solution. So if the end user, they actually get a solution which directly performs the workflow and task that they're actually looking to perform. So these all work together. So you have a lot of different solutions that work together. You can create solutions for example, infrastructure, ecology protection, or outreach. These are all different solutions that come together. And for example, infrastructure solution might bring together asset planning tools, workforce managing tools, crew maintenance tools. These are all tools that you might put together to create a solution for infrastructure. Similar for outreach, we provide the various tools for public communications or creating the dashboards that can be distributed. Similar, you could create solutions for ecology, creating solutions specific for different users within the organizations, if they are people in the field or organization looking for enforcement applications. And then protection solutions. So these are all just examples of how these different components can be put together to create different solutions that create and then have applications that are focused to achieve specific workflows. So in summary, basically ArcGIS provides the framework and process really for enabling these conservation workflows. I'd mentioned this at the beginning, so it brings together all these different observation and measurement, the informing, the understanding, and the teaching collaboration components that are required. And then integrated in all that is really the imagery capabilities to manage the imagery, to create products out of the imagery, to perform the visualization and exploitation of the imagery, as well as to perform the different analysis of the imagery. So these are all the different components. And in summary, I just wanted to also mention, to ensure everybody knew, that all SCGIS members actually get free access to an ArcGIS online organization account. So everything that I've shown you, you can basically directly access, as a lot of it is actually freely available, but you all get access to ArcGIS online organization account. And you can also get ArcGIS licenses of a full license of ArcGIS, as well as access to the Esri user constants can be easily facilitated through the NGO offerings that Esri provides. So with that, I think I'll conclude and hand it back to Janet.
Great, thank you so much, Peter. That was really interesting and really terrific overview of Esri's tools for conservation workflows. Thanks so much. I've been receiving some questions and answers. I want to remind all the attendees that you can type a question in your Q&A box, and those questions will come to us to read. I've also gotten one through a chat, but let me start out. Someone has asked Peter, are all the raster and imagery classification tools available in ArcGIS Pro with Spatial Analyst extension?
Yeah, so essentially we have ArcGIS Pro is the primary desktop application that actually comes in 3 different levels: basic, standard, and advanced. And then we have the Image Analyst, ArcGIS Image Analyst, which is really an extension to ArcGIS Pro that can run even on the basic version of ArcGIS Pro, and that provides all the different analysis capabilities. So all the deep learning capabilities, all the classification capabilities. It also includes tools to work with full motion video, display of, for example, stereo imagery. So for all the sort of collection of imagery, collection of features from stereoscopic imagery, and what we call image space mensuration. That's the ability to work specifically off typically oblique or satellite imagery and be able to sort of take mensuration measurements out of that data. So all that capability is encompassed within ArcGIS, the Image Analyst extension in the desktop environment. That same capability is also available on the server through ArcGIS Image Server. So if you get ArcGIS Enterprise and set up ArcGIS Image Server, the ArcGIS Image Server then has the capabilities of serving the data through these dynamic image services, which I was showing you as you pan and zoom around. The server is processing and returning the data, but it also has the raster analytics capabilities, and that is really about the persistence of this analysis on very, very large data sets. And incorporated into that are all the classification tools, the hydrology tools, and the deep learning tools that are all part of that.
Oh, great. Okay. Thank you. Another question is, can ArcGIS Living Atlas data be downloaded and used offline in spatial analysis, or is it geared more toward pure visualization? We see trends of the geospatial industry moving toward working on the cloud. However, my organization has situations where we need to work on mapping and analysis without good internet connectivity. Do you see Esri continuing to support offline workflows, or do you think this will become more of a niche offering?
So no, we support offline workflows in multiple ways. Things like the base maps that are provided, they can be downloaded and utilized, for example, in mobile applications. A lot of the analysis capabilities are available directly in ArcGIS Online, but you can actually also download some of those data sets. So I showed it very briefly an example of where I'd exported, for example, the Landsat data. You can go anywhere through all the Landsat archive and the Sentinel archive and just basically select an area and download that imagery, and you will have it as a file on disk, which you can then perform different types of analysis on. Obviously, you're not you know, you don't want to be downloading terabytes of data, but typically these applications, people want to just analyze, you know, a small area. If you want to do analysis on very large data sets, that's really where you want to utilize the server capabilities and run that capability next to the data in the cloud. But if you're working on small areas, a lot of the data can actually be downloaded as I showed.
Okay, great. Someone else sent me a message. I really liked the burn scar detection analysis. What tool were you using?
What we'll do is we'll at the end, within a week, we'll basically send you a package which will contain a whole lot of links to the different applications. So wait for that, and you'll get a link to that particular application. We'll give that away as, and we'll show that as a demo application, and hopefully you will see how I actually created it. It's really, you create a web map within ArcGIS. You create a web map, and then from the web map you can just go and say I want to share, and then say I want to create an application, and you go through the wizard and you actually have that application. The application was set up literally within about 10 minutes. So you can easily create that application and customize it to your particular requirements with the particular data sets that you want, and then make that accessible to anybody to use.
Okay, oh, that's great. Another question, I am working in central Indian landscapes and we are understanding conflict issues in the landscape. We are analyzing crop change patterns over the last decade with time series analysis. Our major focus is mapping sugarcane. However, landscapes cover many other crops and there is a seasonal effect. We are doing PCA, as I understand, that's principal components analysis,
Yep.
within several images of different seasons of the year. Will this method be useful to map sugarcane areas grown over the last decade?
That's a technical question. So you're using PCA certainly would be one way to do it, but I don't think it's necessarily going to be the best way to classify the sugarcane. So I think you probably want to look into some of the other classification techniques, looking at typically the object-oriented classification techniques provided by ArcGIS. Those will allow you to better classify the land based on not only the spectral components of it, but also the textual components of it. And then you also have to take into consideration, obviously, the time of the year components as well. So the ArcGIS analysis tools I would suggest you actually look into ArcGIS Pro and the image Analyst extension. That will provide you all the tools that you need to do that type of analysis. I don't think the PCA on itself is not going to actually get the answer that you're actually looking for in that particular case.
Okay. Okay, good. Hope this person listened to that. I also, in a pop-up, somebody else has identified themselves as doing related work, and I'm going to try to connect these people.
Okay.
So one more question. If I would like to use the Living Atlas Sentinel-2 imagery in ArcGIS Pro for analysis, am I limited to 5,000 rows by 5,000 columns using the Make Image Service Layer GP tool, or can one analyze larger areas?
So okay, so in the Sentinel tools that we have at the moment, the analysis is really restricted to an area of about 5,000 by 5. I don't exactly know what the exact value. It's about 5,000 by 5,000 pixels. So if you're doing an analysis, those services perform what we call the on-the-fly processing. So they process essentially an area that is defined. It's not going to process the whole world or something like that. So that restriction is there for 5,000 by 5,000 pixels. If you want to do more advanced analysis, and we have a lot of users that actually do analysis on the Sentinel and Landsat data of a much larger extent, then what you really need to do is to get ArcGIS server and stand that up in the same area as where the data is. So the Landsat data, for example, is actually the data from AWS and is actually hosted in AWS West. The Sentinel data is actually hosted in Frankfurt area. So if you really want to do analysis of a large extent of Sentinel data, the recommendation is to actually set up ArcGIS, and we can help you set up ArcGIS Enterprise and Image Server in the appropriate cloud, and then you can run the analytics on that on massive data sets.
Great. Okay. Good feedback. I got one more message from someone who wants to know more about ArcGIS Living Atlas, asking what are other conservation themed data available on Living Atlas? Are wildlife observations available, for example?
So easiest thing is to actually go and do it. So if we go back to the living atlas of the world, you can actually see all these different data sets. And if we just go conservation, so this basically probably conservation, so some data sets, but we can filter these for different areas. So I don't know all the different data sets. There are huge numbers of them. I recommend you just go to Living Atlas and investigate what's available.
Great. Good. Well, we're at the top of the hour.
Okay.
That was excellent. Thank you so much, Peter. And thank you for, I got one more question. Okay, Charles, you said that LA has over 1,000 wildlife range maps curated by government authorities. Okay, that's
Charles.
great information. Thank you, Charles. We're going to wrap it up now. It's at the top of the hour. Thank you so much, Peter. And thank you, everybody, for participating and for attending our SCGIS webinar series. This is the last one in our series, but please be on the lookout for our fall webinar series with the Conservation Biology Institute. We're really excited to see what's coming next. So thank you, everyone. And please do check out our upcoming annual conference. It'll be right after the Esri User Conference in California in July. Thank you very much. Thanks, Peter.
Thanks. Bye.
Bye.